Okay, so I'd like to walk you through how we got these answers on this practice sheet here. So what I've done is I've kind of made 4 copies of each of the maps, and then I'm going to focus on one area, one district in each map, and walk through all 3 scores for each of those, okay? So I'm just going to actually kind of get rid of these extra pieces for now. So this is just going to help us focus. This is what we call District 1 in class, and I want you to pay attention to just this shape, and if it helps you to highlight it like this, that's cool. If you want to bring a highlighter to the test, that would maybe be a good idea, so you can kind of focus on things as you need to. So for Polsby-Popper, we are looking for, first of all, the area of the district. So let's count the squares in the district. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Actually, the way all of these are set up today, they're going to be 16 areas. All these districts have an area of 16, but we'll kind of walk through the counting each time just to verify. If you have other assignments, you probably will have different totals, so just be aware of that. And then we need the perimeter of the district. So the perimeter, I'm going to start here, and I'm going to count around the district. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, so I'm going to put those 2 numbers in our formula. The area of the district was 16, the perimeter was 22, and then we start doing our mathematics here. So 22 divided by 4 is first in the order of operations. We will get 5.5 there. And then we need to square that next, or multiply it times itself to make 30.25. And then when we divide 16 by 30.25, we get our final Polsby-Popper score of 0.5289. Okay. And for Reock, we are looking for the area of the district, again, which is going to stay 16. And now we need to find what surrounding square do we need for this district. Now this one is, we could double check, but it looks taller than it is long or wide. So width, we've got 1, 2, 3, 4, 5 squares across from here over to the edge. And if we're going height, we got to start down here and go to the top. 1, 2, 3, 4, 5, 6 squares up. So that's going to be our winner there. I'm just going to insert a square so you can see it. And if you're doing the draw menu, by the way, on Word, if you hold down the shift bar, it will keep it square for you. And notice by the time we cover this, this is the square we need. I'm going to just make it empty in the middle so we can kind of see what's happening here. I'll make it orange like I had it before. Oh, maybe I won't. Try that again. Make it orange, and then we'll make it a little thicker so we can see it. All right, and then so that's the square that surrounds the district. You can see it touches exactly at the top and bottom. There's a little extra in the side to side, but that's okay. We do need to keep it a square though, and this square is 6 by 6. So that's why we put 6 squared in the bottom of this formula here, and that becomes 36 when we square it, and then 16 divided by 36, and there's our final Reock score of 0.4444. All right, now time for the convex hull, which is probably the one we struggle with the most. So we're going to insert, and I'm going to make a shape that will surround this. I'm going to pick this one here. I'm just going to start in this corner. I can go down here, and then I start to see it caving in here and here and here. So I want to stretch all the way down to here as I'm drawing around the shape. And then I'm going to go across the bottom here, and then I'm going to go up the side, and that's fine. And then here I see another cave in, so I need to stretch across that. And then I'm going to finish my shape by coming back to where I started. So take a look at that and see if that makes sense, that we filled in all the places that were caved in. Again, you can kind of imagine wrapping the shape in a string, and this is kind of where those lines would fall. Or think about wrapping it in saran wrap, something that's not going to fall into those caves, into those holes. Okay. And again, I'm going to make it transparent here, and I'll change the color back to what I had before. It's really fighting me here. And I'll make it a little thicker so we can see it. Okay, so now our job is to find the area of this convex hull, okay? Now what I see is that I have all 16 squares that I started with, okay? Let's see if I can add a line here. Okay, so I have the 16 squares that I started with, so 16 original, plus I see 3 little small triangles that are 1/2 each. So let's add those in. And then I have one big triangle up at the top here that is new. And what I notice, and let me just, I don't know if I can draw this well. Let's see if we can make this work here. This triangle is kind of half of this rectangle right here. This rectangle that I've shaded here is, you can kind of count, is 8 squares. It's 2, 4, 6, 8, counting down the rows. So since the triangle is half of the rectangle, and the rectangle is 8 squares, half of 8 is 4. Okay, I'm just going to get rid of that because that was just a technique there. And again, if you are more comfortable using 1/2 base times height for your triangles, that's fine. Now, as I add all of this together, I'm going to get 21.5, and that's where I got this bottom number here. And again, that top number is the area of the original district. Notice that 16 happens here, and here, and here. It is the numerator, or the top, of every single calculation that we do for these problems, okay? All right, so that's the, and then we divide that, we get our 0.7442 as our final convex hull score. Now, when we move down to the next district here, okay, I'm going to actually get rid of the old markings that I had here. And again, I've highlighted the one that we're focusing on, so this is the shape, all right? And this one has an area of 16 also. I just count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I did find the perimeter was the same, but it comes out a little differently where it all is distributed. So if you start in this corner, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Back to that same corner where we started. So again, we plug in the 16 and the 22, and the math is the same as above, so I didn't put all the steps in. If you want to look back at District 1, you can see that there. All right, and then we got the same 0.5289 for our final answer. Then Reock, we're going to make a square around our district. Now I can see that this district is, let's see, 1, 2, 3, 4, 5 squares high, and 1, 2, 3, 4, 5 squares wide. So actually that's going to be a very nice surround that we're going to get here. So as I surround it with the square, you can see that it fills it right there, okay? And I'll make that transparent so we can see it better and color it the way we had it. And a little thicker. There you go. Okay, so that square there that is surrounding our district is 5 by 5. So that's where the 5 squared is coming from here, and the 25 there. So 16 divided by 25 is 0.64 for a final Reock score. And then convex hull. Now we're going to try to draw around this district and not fall into any caves. All right, so we're going to insert shapes, take our flexible shape here. We're going to start up at the top here. We can draw straight down here to this corner. And now we're going to skip over this cavey part, and we're going to click in over here. See how that stretches across that gap? We can go to this corner, and now we've got another whole cave gap here that we need to bridge. So we're going to stretch across to the next vertex way over here, and then up, and then over. Okay. And again, I'll make that transparent so that we can see where it's really going. Change the coloring and a little more thickness. Okay, hopefully we can see that all right. Okay, and now what we'd like to do now is we'd like to figure out how much more area we have here, or what the final area of this is. So let me do that addition in here. Okay, so again, I have all the original squares that I had before, so I'm going to start with my 16 original. Oops, the space. All right, and then we're going to add in, I have one triangle here that I have added, and that triangle covers, sorry, that triangle, actually I could just kind of motion it here. So this triangle covers these two squares, it cuts them in half. So these two squares being cut in half by that triangle means that the triangle is covering one whole square of area. Oops. Triangle, okay. And then I have up here, this whole orange area inside of the blue line is also included. I've got one entire square that's not part of this big triangle here. So I'm going to count this one square separately. So I've got one whole square. And then I've got my large triangle, which is here along this area here. Now this large triangle is cutting this big rectangle in half, and this big rectangle covers 6 squares. So this big rectangle being worth 6 and the triangle being half of that means that the triangle is worth 3. So I'm just going to kind of label that large triangle. Hopefully that helps. Okay, when I add that all up, I've got 16 and 17, 18, plus 3 is 21. So 21 is the area of my convex hull. And when I do that division, then my final score is 0.7619. Okay, I'm going to clean this up just a little, make it a little larger so we can see it outside of the, there, okay. All right, when we look at District 3, this is the orange district, so it's kind of easier to spot here, so I didn't highlight it, but we're going to keep our eyes on this orange area here as we work. I'll take these out and we'll start again looking at those, where they come from. So starting with Polsby-Popper, again, we've got 16 squares on the inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay? When we go to do perimeter, I'm going to start in this little corner down here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So when I get back to my corner where I started, I have 30 as a perimeter. So I'm going to take that 30 and put it in the formula where it belongs. I'm going to put the area of my shape, 16, up at the top. Now I take 30 divided by 4. That's my first order of operations. I get 7.5, and I take my 7.5. That needs to be squared. So 7.5 times itself, or you can use your square button on the calculator. It gives us 56.25. 16 divided by 56.25 is our final answer of 0.2844. Okay. Now with Reock, we need to surround this orange thing with a square. I can definitely see it's very stringy, so let's see how tall is it. It starts here, 1, 2, 3, 4, 5 squares tall. And it is 1, 2, 3, 4, 5, 6, 7 squares wide. So we are going to need to use a square that is 7 by 7 to surround it. Okay, so I'm going to start here. I'm going to draw that whole square. Keep going until you surround the entire thing. I got it a little off there. I'll fix that in a minute. Make it transparent so we can see it. We'll change it back to orange and make it a little thicker. Okay, and I'm actually just going to shift it back so it fits better here. There we go. Okay, I was got a little crazy while I was drawing there. All right, so this is a 7 by 7 square. So when we go to do the Reock score, first our area of our district is still 16. The surrounding square is 7 times 7, right? Because each side of it is 7. To find its area, we take 7 times 7. That's 49, and then 16 divided by 49 for a final Reock score of 0.3265. When we do the convex hull, And I'm going to take my flexible shape here, and I'm going to start just in this corner here, and I'm going to draw down to the next vertex, the next corner, and then I need to skip over this cave here diagonally, and then I'm going to come along the bottom, and now I have a couple more caves to skip over diagonally. I can do it just like that. Then I can go up to this corner. That's fine. This is still convex. This is still convex. Now, oh my goodness, look at this. We have a giant cave to jump over here. As we're drawing, we're going to draw all the way over to here. Okay, see, if we dip in anywhere else here, we're going to just create a new cave. So we got to go all the way to where we started to finish off this shape. All right, and let's make it transparent and color it correctly. And a little thicker. Okay. And then, so what we're looking at here now, we want to know the area that's all contained in here. All right. So we have, again, 16 original squares. Those are the orange ones. And we're adding this little triangle here, which is worth a half a square. And here's another half a square. And here's another half a square. So let's put those all in right now. Oops, I need a plus there, not an equals. Okay, and then I have this huge amount in here. So here's what I'm going to think about. I'm going to think about this as this triangle, okay? And then I'm going to think about the leftover whole squares that I have. So I'm going to do something for myself just to hold that thought. I'm going to give myself a rectangle. That's going to map out the rectangle that triangle uses. Okay, and I'm going to just block that off for a moment. Okay, now what I'm going to do now that I've got that done is I'm going to count all these extra squares that I didn't count, that I won't be counting as part of the triangle. So here's 1, 2, 3, 4, 5, 6, 7 extra whole squares. Okay. And then, as I said, I've got this square here. Let me make it transparent real quick. Okay, so this square right here is where that triangle sits, and it is 1, 2, 3, 4, 5, 6, 7, 8 squares. The triangle cuts it half of that, so the triangle takes up half of 8 squares, so the triangle takes up 4 squares. So 4 squares for the large triangle. All right, and let's get rid of that extra piece there. Okay, so adding this all up, we've got 16 and 4 is 20, 27, 28 and a half altogether. So 28 and a half is the area of that outlined blue shape. And 16 is our original district that goes on top. When I divide, I get my final convex hull score of 0.5614. All right. Our last district here, and then I'm going to take a break and I will start a new video for the other page. All right, so look for that link on your Blackboard. All right, so now we're looking down here, this bottom district here, and I've outlined it for us or highlighted it for us so we can find it. That's what we called that District 4, I think, when we had it up on the board. So again, this one will have an area of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares contained in it. So that's our area there. 16 goes here, and here, and here. Okay. Now the perimeter of this district, let's start in this bottom corner here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so this has a perimeter of 30, and we actually had that up in this other answer here. So that's the same math is up here, and it's down here, and we get our final answer of 0.2844. All right. Now, to surround this district with a square for the Reock, we got to go all the way across this shape. Notice that it has a width of 8 squares. It's the whole amount of this box. So the box that we're going to draw to surround it is going to be the box that it's already in. okay? The box that all 4 of these districts are in. So I'm just going to do that really quickly for us to visualize that. And this box is 8 units across and 8 units high. Okay, again, perfect square. You have to have perfect squares. You can't make a box that is 8 across and then 5 units high. That's not how the method works, okay? It's true that we could make a smaller rectangle and, it could be shorter and would still surround our district, but that's not the Reock method. Reock uses squares only. Okay, so squares only. And so we need 16, and we're going to divide that by the area of our 8 by 8 square. So 8 times 8 is 64. 16 divided by 64 is our final Reock score of 0.25. All right. And then convex hull. Let's get my flexi shape. All right. So I'm going to start up here, and I'm going to go down. And so far, no issues. I'm going to go across. So far, no caves. And I'm going to go up. So far, no caves. And I'm going to go over. So far, no caves. And then here's a really deep cave. Okay. So if we fall down anywhere in here, we're going to kind of stay cavey. So what we want to do is we want to stretch all the way up here to finish this shape off and make it completely convex. Oh, you know what? I'm going to do that over because I noticed I left a cave right there. Let's try that again. I got to start a little sooner with my flexi jumping here. Okay, so again, starting from here, going down is no problem. There's no caves yet. No caves yet here. No caves yet here. Okay, now I realize I have to jump all the way from there up to here. Okay, now I've got a completely convex shape. No caves anywhere in that. Okay, let's make it transparent so we can see what's happening under there with the squares. And there we go. Okay, so now as far as what's new here, so all the yellow squares I know are my 16 originals. And what's new? We're going to add in all of this that's orange and then some of these blue ones up here, okay? Now again, I'm going to kind of mark out for myself where I see my triangle taking up space, okay? I see a triangle that starts here in this corner and it goes across and up to here, okay? So let me just mark that off for myself and so I don't double count any of those squares. Now, all of these down here that are not yellow are new to my convex hull shape. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 new whole squares. Okay. Oh, I always keep hitting I instead of, all right. And then now we're going to talk about our triangle. Okay, now notice that I've mapped out where the triangle sits. It sits on a rectangle here that is, let's make that see-through for a second here. So this rectangle here covers 2, 4, 6, 8, 10, 12, 14 squares. Okay, so that rectangle is 14 squares. My triangle is cutting that in half. So half of 14 is 7, okay? And I will label that as my triangle amount, okay? I'm going to take this extra marking out because that was just a tool for me to think, all right? So I have total here 16, 26, 33 holes, 33 squares in my convex hull, or total squares, or parts of squares, right? Together it's 33 squares worth of area. That's the best way to say that, I guess. All right, so 16 for my original district, 33 for the new convex hull. Notice I've added a lot more area in here, okay? So when I divide those, I'm going to get a convex hull score of 0.4848. All right, and like I said, check back and we will get you I'll do the video for the page down here next, okay?